All right. Okay. This should be working now. It's pretty cool. Let's see how to grab a link to this and share it. Damn. Whew. I always get so nervous before streaming. I'm literally sweating right now. All right. Whew. So, all right. Cool, cool. Well, might as well get started, I guess. So we've got the stream contents. Ooh, this is from last time. Basically, this stream is titled Day 1, but technically I've already done a bit of streaming on the side so far, and that's fine. I actually had to, unfortunately, completely unlist that the previous day's stream because um, I accidentally leaked my personal email address, which that was a mistake. I didn't realize it until after the video, but yeah. Anyways, here is my new email. Um, not new email, it's my professional email, I guess. Um, but yeah, yeah. All right. Um, let's see. Not gonna lie, I think I'm going to try. Oh, whoops. Quitting this. Um, there we go. New stream contents. So now today is going to be more about damn. All right, today is going to be more about reviewing Claude Code's generations, taking a look at a prime example of a piece of software I made with Claude Code yesterday, actually, and kind of understanding it, taking a look at the plan that I used to write the code, the plan I used to base the output code generation off of it, and actually review the code itself. Let's see, review the plan.md and the code of a project I made. And what is that project, you might be asking? That project is actually, it's this cube right here. This little spinning cube in the corner. Yesterday, as a dev stream, I wanted to basically spend that time setting up my streaming environment, and I decided that I needed a little graphic because I'm not actually showing my face in the stream. I thought, why not instead have a little, uh, some sort of graphic floating in the terminal while I use this, and that is the graphic I made. And I basically like it took 2 tries, but I made it one shot at it the second time. First time it was fine, but it kind of was way too zoomed out for this little view here, so I had to make another version with a zoom zoom feature, which allows you to just kind of zoom in and out as you want. It's pretty cool. Um, there are 3 different ways that it renders. One is just the rendering the ASCII characters text. Pretty cool. Other one's a wireframe box. And then we've got the colored box, which I think is the coolest part. I can also speed up and slow down the rotation, but the speed looks fine. So what is it that I will be doing today? Well, we shall check it out. So this is the cube that I made, the code that I generated, and I actually, from yesterday's code, after the stream, I dug through it, the code, to kind of understand what was going on. Oh, something I actually forgot to mention again. Part of this is, part of the goal of the stream is actually to answer the question, are we cooked? Are software engineers cooked across the industry? That was the goal of yesterday's stream for me to figure this out, and I couldn't arrive to an answer during stream yesterday, but after the stream, I was sitting around and thinking for a bit, and I wanted to just kind of, I was just kind of shooting hoops outside for a while, and I realized that the answer to this "Are we cooked?" question is a resounding sort of. Um, so the key thing with that is, um, for even more context, this is the code that I made. I'm gonna explain my thought process here in a bit. So you see this little spinning graphic here. This is the code I made. I generated for basically I generated it in two shots. So or well, sort of. Let me explain more. Yesterday, I wanted to generate this cube program that you can see spinning in the bottom, and I did it by writing a plan, asking Claude to generate a plan, and it generated the plan. And the plan was cool. This was part of a two-step strategy, basically, uh, for context management. Um, create a super detailed plan spec document that has exactly what you want with the project, and then in a second session, a second prompt, you just asked it to follow the plan. Boom, and it spat out a project. Um, the yeah, basically it spat out this. This is the plan I used to generate this in a single go using Claude Opus 4.6. Now I didn't fully understand this, like what I was looking at first initially, honestly. Like this plan gives a decent overview. Like you can see, we got this terminal program written in C, renders a spinning cube. Oh, I can actually select this with my cursor. That's better. Decisions we made. Tmux integration. This isn't a huge deal. Zoom. This was the biggest thing, but yeah, we got speed, left and right for slower, faster spin. 3 different render modes. Then we got the key actions here. Um, damn, okay, this isn't scrolling, whatever. Key bindings, we got the file structure, single cube.c file, cool sections inside, terminal handling. Then it goes into like more of the details. So what exactly is the terminal handling stuff? Frame buffer to heap allocated arrays. This kind of looks a bit like jargon, honestly. I couldn't exactly follow what was going on until I basically decided to go dive into the code. And here is something I'm going to take a note of right now. Um, this, what I'm planning to do, or what I'm trying to do here is basically use a way of working where I have actually wait no so there's the use usually so level 0 strategy for using Claude Code is prompt, and then you generate code, and then you reprompt, then you regenerate code, and then you keep on making edits over time. you make more like the initially the prompts are large, the code output might have errors, you make more targeted changes, more prompts, get more larger and larger code piled on. And the key idea here is that we talked about this yesterday. All code you did not personally write or review is tech debt. This is the key with Claude Code or even LLMs, using LLMs to generate code. Um, all of this is tech debt if you do not fully understand what is going on. It can be quite decent tech debt, like it'll run and then stuff, but and actually as you will see, I will pull up the code, the C code, and you'll actually be able to view what I was looking at. Um, it kind of wowed me a bit, honestly. But even then, if you don't exactly know how it is, how it's working, and there are changes you need to make, but you don't know what changes to make, that is kind of tech debt. The level one approach that I was trying out yesterday, and I've tried this out a bit at work as well. Prompt plan code. So instead of directly prompting into your code, you prompt Claude Code or whatever agent you use to create a plan.md. And you can kind of work with this agent actually to build your plan.md. You can ask it to ask you clarifying questions about the architecture, about the build process, about the targets, about style guides, reference materials, any sort of um, interesting commands it should know, interesting libraries it should use, the names of libraries, specific command, like stuff like that. You can actually put that into this plan MD. And if you don't exactly know what you're doing with the project, the goal is to basically use Claude to help you think. You can iterate on this plan. And once you have the plan, you quit and then you use this plan. Actually, let me just highlight. So first stage, prompt into a plan. You can reprompt, regenerate the plan, edit the plan, reprompt again, plan again. Then once you have this good plan MD spec, like here, you basically use up a context window of a single session to work into generating this plan. Then start a new session, new context. This session only has follow the instructions laid out in this plan. Ooh, that's actually kind of cool. I was right clicking on this word plan here. This is in Vim. All right. But yeah, so follow the instructions in this plan and generate the output code. Let's take a look at that. Uh, yes, it is cube.c. All right, this looks pretty interesting. Uh, it's got its own little sections thing at the header at the top. Um, in fact, we could probably just step through these sections if we really wanted to. Maybe not, but yeah, so it's got a bunch of these constants defined here. Oh yeah, I threw in a to-do here. This didn't fully understand the purpose of these static int calls, what exactly that means. It just means that these are basically global variables within this file, I think. Um, term restore, term setup. Ooh, this is actually going to be interesting. Let me uh, pull up where I initially found it. So this is the main loop. This is where all this code is running. Um, actually, I can just go through this honestly. If you look at this code looks pretty good. It looks very structured. It looks like it could pass code review in prod or whatever you want. It's got shade lens. It's got vectories. It's got yeah. This is the rotating. It's this projecting. It works. Um, And I mean, it isn't perfect, of course. Like if you can look here, oh, whoops, in this cube, you can see that sometimes you can like kind of see these little colors bleed through one side. I think that's just a way, an artifact of the sampling mechanism that they use, um, the rendering step. And in fact, that's one of my goals is to try and fix that issue. Um, but uh, yeah, this, this code looks pretty good. This is a process input function. This is basically the keys you can press within this terminal window. Um, Bam, one, you can see mode 1, 2, 3. Q is to quit. R is reset the what the goddamn. I guess yeah, completely reset it. Well, the more you know. Yeah, plus minus, zoom in and out. Um, but yeah, you can see this looks like fine code. And this actually kind of wowed me. This is the first time I was like, wow, this is good. Signal handling. What exactly is this? I didn't know initially. Um, and then so you can see it's like, oh, we've got like signal sig int. What is that? Sig term. I don't know what that means. Sig winch. No idea. Well, if we go back actually, um, on sig int, we can basically see these are functions that take in an integer pointer of some kind, and I think this is the oh yes, they take in a pointer, and are they taken an int? On sigint is a function that takes an integer pointer, and what it does basically is I don't exactly know why it casts this s to like int to void. I don't actually know what that means. We can probably ask Claude Code about it. But then it sets running to 0. What is running? Running is a variable that basically keeps the main loop running. It's the condition in the while loop. So if I do a running check, bam, uh, there we go. Yes, running here while running. Another static global variable within this file, I assume. Um, this is signal handling. It's basically like JavaScript on click function. Um, when I saw this, because I've done a bit of JavaScript and a bit of web dev for work and stuff. When I saw this, it kind of gave me whiplash because I realized like, oh my God, this is like JavaScript or like kind of web dev patterns. Like you have um uh I don't know if this is continuation passing style, but I mean you can sort of see this is basically like signal processing, signal handling, like in what you might do in HTML and JavaScript, putting a on click function on a button to get handled. But these are signals from the sort of whatever environment this is, which actually, that's another thing. I have no idea how this works, what this is doing. This is, oops, what the hell? This is a spinning cube function. I just wanted something that would render in the terminal. Instead, it actually opened um, a terminal display method that creates a little window, like an application window almost, and you can do quite a lot of interesting things in this window. You can just like make this, for example. That's cool. I could not have I have no idea how this works. And that's kind of interesting because this all started from a single prompt. Um, and the prompt initially was something like create. Actually, I mean, I can actually just pull this up. Let's see. I'll explain that in a second. What the hell? Um, the initial prompt that I started out was this a single sentence. Oh, I mean, okay, this is never mind. This is basically just the prompt for creating the zoom, whatever, whoops. But the initial prompt was maybe like a couple of sentences, like a paragraph, like create the spinning cube. I want to be able to render a spinning cube in the terminal written in C. Um, you can have three render modes, one ASCII black and white text rendering, one a wireframe cube, one colored rendering. And it should be able to rotating cube. It should be able to zoom in and out. Um, that basically was it. That was, and if you consider what an AI agent is, or what a LLM, a generative AI model is, at its core, it's basically like neural networks are function approximators, pretty much. They just take in an input and they run it through their neurons and they spit out an output. And you can train it on a set of input output data pairs to basically generate this function approximation. Um, and the way they do this with, I mean, the combo of like uh, unstructured versus structured machine learning, they build the pre-trained models using just a, I don't know, ton of unstructured data, I assume. And then they reinforcement learn, train it so that you have more of this X to Y function mapping. But this is all super abstract. I literally just the ability to go from the X, the prompt, just being like a paragraph of like, here, give me the spinning cube written in C, to Y, it spits out the plan, the full plan, which I showed you back here. This and then from that, another prompt, go create the project from the plan.md file. On just that single prompt as an input function, it basically outputted a bunch of tokens. Um, some tokens to read. Basically, it emitted a couple of ls files. It emitted a uh, read command file, read command in this form of tokens. The Claude Code harness read the file, put that into the context window. Um, and then from there, with this updated context window, just next token predicted its way into writing a bunch of bash commands, writing a makefile, writing this cube.c program. All of this is just a bunch of next token predictions from what is functionally um, basically just create the project from the plan.md, and then the plan.md is passed into that context window, I guess. So technically there we have our answer, because it's not just this X that's the input. The input is, whoops, let me grab my mouse. The input is this sentence plus the contents of the file that it read, which is the plan.md. And then from that, it basically spat out all of this. I think you can kind of not exactly go to see what I'm getting at, but with this plan.md, this is a very, very detailed prompt that I basically, for a project that I basically got Claude Code to write for me. And Claude Code asked me about it. Claude Code asked me for specifics. It asked me, in fact, Claude Code had the idea for these three rendering modes. It gave me the, or no, it gave me the different modes as options, and I said, um, just do all three. And then it gave me the idea for uh, uh, this is changing the spin speed of the cube. I hadn't even thought about that as a feature that I could ask for or would need to ask for, but it asked me while I was trying to come up with this plan document, and I said, sure, that sounds awesome. That surprised me. And it created a super prompt from my initial prompt of, eh, give me a cube that can render as in terminal written in C. You can kind of see it, with this was a single one shot. The X was my initial prompt, give me a cube written in C that can render in the terminal with ASCII characters. It spat out this. And then we feed it in again into a new context window, implement this, and it spat out the code. And that is crazy. I could not have written code like this cube.c file, even if I had been learning C for years. Maybe a year, but or two, but even still, this is like very professionally written code. And of course, making a spinning cube is like for graphics programming, it's the the it's not even it's like level zero. It's like kindergarten, like baby steps type stuff. This is not treading on new ground in any sort of way. But even still, this is crazy to be able to like pull out of this model, to be able to pull this information out of the model and bring it to life running in my terminal screen. That's awesome. Now, are we cooked? Um, and I don't think so. I mean, software engineering as a field, as a discipline, as an industry is going through a lot of changes right now. I think the biggest one, honestly, is the might just be the macroeconomic industry factors less than AI, perhaps. Like jobs just are not as plentiful as they used to be in the 2010s era. Um, we had a tech had a great run, and the run is still going, but I mean, uh, whether or not there's a bubble, I mean, it's, you know. And then there's this AI coding stuff now, which, um, like, like the work that I get, um, at my job, the real bottleneck is almost never the actual code. It's having the proper spec written down for what we want to write, having the requirements set in stone. um, because there's been plenty of times where I've been given an incomplete set of requirements and I've known that they were incomplete, and uh, a boss had been like, "Yeah, I mean, just deliver on it. We'll get new requirements in a bit. These are wrong for now, but even then, just have them ready. We can change them as needed." And that's kind of what the job is like. But now with AI, LLMs, we can basically cache those requirements into a plan.md and then generate the code on demand, which is pretty cool if you have it separated into its own little module chunk as needed. Um, that could work pretty effectively. Um, Now, let's see what to do, what to do. All right, I guess I've kind of given this a little bit of a spiel here, just kind of general talking about stuff. Um, Now, yeah, I guess I did have a goal for this stream, which is to try and see if I can fix this rendering issue. I know nothing about 3D rendering. It seems hard. In fact, I'm astonished that it even this Claude Code managed to one-shot this as it did. That is crazy. And now let's see if we can keep the magic alive. Let's see. I'm going to copy the plan. Cube updated rendering. Copy the plan. Zoom plan. Then put it into cube. my terminal skills are not the best, but yep, that looks good. Now we go into Claude and we say um, currently if the uh, cube is large enough, I can see holes within the cube faces such that I can, as though it is a porous material. What rendering is, oh, primarily the mode 1 ASCII rendering and the mode 3 full color rendering. I guess there was another issue I wanted to tackle as well, which was actually, I guess it's not super visible here. I might pull it up later. This wireframe, when it's ballooned out to the max size, it gets a bit finicky. But all right, anyways, how can I? What updated rendering strategies would you recommend? Wait, to prevent this issue from happening, research and put your findings in the plan.md file. While that's going, there's something a couple of things I want to point out. Um, the way this works, we're basically prompting to the plan and reprompting and replanning. Huh? Home. What the hell is this? grep I cube. I don't know what that command is for. I don't necessarily. I'll see what it does here. Okay. Anyways. Um, maybe I should. Maybe I should add a. Um, I might need to add debugging to this program where I can hit a key and it will emit a rendering, like a snapshot of whatever is on the like whatever the frame is at any given point in time. That could be useful actually. Just emit to a file. Um, all right. Well, this is doing its thing. Yes. So uh, what I was talking about a couple of days ago, or not last stream, I guess. The core idea is um, use the plan.md as a ground truth for the code. You can generate the code whenever you want based on the plan.md spec. And I mean, I guess as plan.mds get larger, you can basically split the plan.mds into modules, and within each module have its own plan.md. And uh, I have Discord going on in the background. Yeah, damn it, I probably have to turn that off. But yeah, anyway, so you use um, oops, you use the um, damn, I got derailed a bit. But anyways, yeah, so you use the plan MD as the ground truth to generate all the code as necessary. Um, and yeah, like the code itself is kind of an artifact that you can go look back on, read through, understand, um, take a better look at, and then you take those findings and you put them into the plan.md. You alter the plan.md as needed. You see what are the issues, what are the, how can I basically split this code up into different modules, and then with that updated plan.md, the plan.md is always the ground truth of whatever you want, because then you can do a bunch of interesting meta strategies. You can have Claude Code do extra research as into the plan.md, like what I'm doing right now, um, and then use that research to basically generate a better or an altered version of the code. And you can go back and forth with this. If it turns out that I might need to split the actual rendering logic, like the calculations part from the displaying to the screen. Um, that might be what I might need to do, but it should work. Like all of this code, this is just literally a frame buffer that is being filled up with ASCII character. Oh, what the hell? I did not expect it to do that. Where is the cursor now? Oh, there it is. Uh, huh. All right. Well, can I read through what this is? This wants to add a lot of lines. That is interesting. All right. Let's so rendering fix. Oh, this is adding the rendering fix itself to the plan.md. This I don't actually want to do. Um, I want it to basically give me this actually, you know what? Okay, I would have wanted it to just spit out the research, give me this information, so then I would be able to say, all right, go with this specific approach. And you know what? I'm just going to do that actually. So let's see. What are these two? The things here are um, fix holes and face fill. God damn it. Adaptive per axis sampling. All right, that is cool. What does that mean? Scale and dynamically so the object space step size maps at most one screen cell. Um, okay. Pros still point sampling. Oh yes, that actually is uh, an interesting point. I believe there we go. So with the reason why it is off at times is because it's point sampling. So the surface is being generated by a bunch of points. Um, like it has this I don't know. Anyways, you can sort of get this idea of this is basically all calculated using 2D, but each side of the cube is a square, and the position of the square, the rotations, each of the 3D rotations, it's basically a plane, but it has a like it has a bounding box, and the specific points on this plane within this bounded square that get rendered, I believe that is all just from like space sampling, basically. It'll sample each of these little things bunch of these. And from there, it'll basically, that's how it renders um, the output. And some of there are holes. So I think that's kind of what this approach is trying to address, like an updated away clamp. All right. This is screen space triangle rasterization. This is minimal change, complete fix. Um, huh. Interesting. What I could actually do is never mind, never mind. I have these three approaches here. For now, this is kind of a bit of a jank fix, but what I could do is literally just alter. Um, Actually, this isn't even. Let's see, approach one, adaptive sampling. Uh, Approach two, triangle rasterization. Yeah, so this isn't actually. Um, hmm. I guess my thinking is here that we can basically change the decision as needed. But oh, you know what? I'm going to. Okay, so what are these? Zero gaps possible. Cons, 100 new lines of code. Must maintain a list of face. All right. Gap guarantee. You know what? All right, let's see what this does. We are still in kind of like an exploratory mood. If I don't like it, I can always just nuke this and basically restart from scratch. So yeah, we'll see. Um, I don't know. I could do a bit of Git uh, version control to handle that later. Um, all right, very cool, very cool. Um, Now let's. I think we'll probably have to go into the plan.md here and oh mother god damn it. I'm just gonna exit that. All right, and let's actually kind of see how this is updated. So all right, we've got this implementation details, one terminal, creating the window, detecting the terminal, hiding the cursor, screen buffering, exiting, yeah, frame buffer, math, render modes, output emission, input, cool, render loop. Actually, as you can kind of see here, what I've been doing, like what this, I don't know if you can remember necessarily, but these 7 sections um, here in this plan, see terminal handling, frame buffer, 3D math, render modes, output emission, input, all of this is actually basically the code in the this like the code that's generated follows the same structure as this sort of plan MD stuff. And then we have this implementation order. Um, 3 math. Okay. Okay. I see now. This is, I don't think this is what we want. I'm gonna have to nuke this. Let's see. RM. Instead, what we want is I'm gonna have to recopy the plan over. Um, yep. And now we go here. Oh, mother, god damn it. I I forgot you can just throw in the plan into Claude as a command line argument and it'll just read through it all. Okay, that's actually kind of cool, but whatever. Now let's go back to Claude. No, throwing in that plan.md. Uh, there is an issue with the plan generated by this plan where it um, renders a cube. Whoops. Cube renders and spins properly, but it doesn't. Each face of the cube is not completely filled, and it has gaps. These gaps are more pronounced when the cube is zoomed in more. How might I update the rendering logic for modes 1 and 3? Shaded ASCII cars and colored faces so that this isn't an issue. Damn, I actually might have to leave in a bit. Whatever. Might update the rendering logic. That's misspelled rendering, but that's fine. Research and print and answer. Okay, I'm going to buy the plan.md in this directory. Search and print a series of potential solutions. Okay, there. We just want the solutions printed out to the screen. We don't necessarily want it just kind of thrown into the plan.md file. So now it's just gonna go thinking, it's gonna go doing its thing. Yes. Let's get that done. Now, while this is going on the side, I actually wanted to. What the hell? Where is my cursor? Nope. There it is. All right. I wanted to throw in a couple of thoughts. Oh, goddamn. Okay, I guess this little experiment is a bit screwed up because it saved a memory of what it was doing. So, anyways, let's see. This experimenting around with Claude Code has given me an idea. There is a talk on YouTube. I love this talk by a guy named Eskil Steenberg. It is called Finish Your Software. This guy has been writing C for over 30 years. He's built entire games in C, game engines, game rendering, everything. It's just all pure C. He uses mostly C89. He uses some C99 features as needed, but his core thing is screw C++, that like is a bit of a shit show. He never got onto the train, and in fact, now because all of his libraries are just pure C, they can run everywhere because C is a stable ABI. C is never going to like it is never going away. There will always be a C compiler that exists um, as we live and breathe. In fact, there will be C compilers out there when we are dead and in the ground because C is just that important. Linux is basically the ocean of all like computers, operating systems. Like all of the world's infrastructure, compute infrastructure depends on C. C is a stable ABI, and you can program against stable ABIs to basically do incredible things. Let me just do stable ABIs. C is a stable ABI. HTML, JS, also technically stable ABIs. Like the browser is also not really going anywhere. If we are going to be stuck with C as a language, we are also going to be stuck with JavaScript. Unfortunately, that is just how it works. Of course, writing a JavaScript compiler and a linker and well, is a lot tougher than writing C. However, there's another stable ABI, OpenGL SDL2. Um, SDL is a kind of a complicated, not exactly complicated. It's tough to get into as a beginner, I will say. I tried it out in the past. It's kind of weird. It works, you can build games and stuff, but it's kind of hard to use. It's unwieldy, especially if you don't have previous C experience. However, LLMs know these agents can write good C. They can build good programs. Why do we need to be stuck with basically most of the world's software being through e-commerce, through websites, web dev stuff? Why do we need to have it stuck in JavaScript through the browser when we can write better native code? We can write more performant, higher quality native code. And again, it might crash because C is, it's complex. It's not complex, but you can basically, it's basically you're out there all alone, kind of doing your own thing. You can kill yourself with C if you want to. You can crash your program. You can do all sorts of crazy things, but the quality of the code, the performance you get just by writing C can be incredible, especially for games, especially for basic desktop software. And you can use these agents to write C for you, which, speaking of which, this is completed. So let's check this out. You have a fixed 28 by 20 grid in the 3D face space. Okay. Face samples is 20. Each sample projects one screen pixel. When zoomed in, a face cover covers far more than 400 screen cells. Gaps appear there where there is no sample project. That's kind of exactly what I was mentioning before. These are the gaps, the projections. I mean, the patterns they appear in are the gaps are kind of pretty enough, but is this a problem that this can fix? Yes, adaptive sampling easy. Uh, huh. Large zooms get expensive. Okay. This is the size of the O of n zoom squared. God damn, this is good. Wow. This is all from next token prediction. Of course, next token prediction and then RL'd over countless code bases, generated conversations and stuff. It's still, let's see, okay. Scan line rasterization. This is robust. The algorithm. Project the four corners of each face. Oops. Pixels covered, not O of zoom squared. More complex to implement. Handle edge cases where face is nearly horizontal. All right. Yes, I want performance and I want correctness and I want robustness. um, update the plan.md spec so that it includes scan line rasterization in the as a description in the render mode and steps to implement. In addition, should we do come up with test cases? We can do asserts, I guess, potentially. Because all of this is just in a single main cube.c file. Update the plan.md spec, so that includes scanline rasterization. Yes. Is that it? Whoops. Yeah, so previously it was okay, yeah, we can honestly just kind of tell this Claude what we expect. What we expect is if someone were to read the new plan.md file and implement it, they should have very little problem figuring out how to integrate scanline rasterization for their implementation. Also include a brief description of the bug this is meant to fix. There we go. And we are going to update the plan.md. Or this is going to update it for us. Bam. Like here, we're not even using anything too complex like SDL. It's just all like screen rendering. But whew, even then, this is really not bad. This is quite good. I don't know much about C. I know a little. I know that um, you know, memory management is complicated and you've got a malloc and a free um, as in complex ways. Oh, damn, this is another just oh, never mind. Bug context. Step 2, step 3. Yeah, sure. This is a single edit. Okay, we'll allow that, and I want to see where it makes the next edit. Um, but yeah. Oh, there we go. All right. Cool. All right, yeah, while that goes, what was I saying earlier, bro? All right, I have homework for anyone who is watching this talk. Oh my God, what the hell? I actually have no idea what just happened. Um, let's see. All right, whoops, that is unfortunate. Hopefully this is not just like running in the background somewhere. All right, bam, yes, there we go. All right, yeah, there we go. It's done that. Oh man, let's see, CD. There we go. Now we've got that back. Looking good. All right, that is done. Now we can actually literally just do Claude PLAN.md, pass that in. Now, this brings me to an interesting point. Ralph looping. Where the hell is this cursor? There it is. Okay. The concept of a Ralph loop is basically you pass in a plan to Claude Code, and it breaks down a project spec into a series of goals. It, oops, yes. The whole concept of a Ralph loop is, imagine if we passed in this plan.md and we told it to basically, we gave it a command to basically, uh, if there are no current steps, generate a list of steps to do to complete this project. And currently we actually did have a series of like implementation order steps. We can maybe look here and find them. Yeah, I guess. I'm not sure if we can find that here at the moment, but yeah, anyways, um, it, within this plan, you can have a series of steps, and then you can have these steps being checked boxes. And the check boxes are like left to be checked, but they're all start blank. And you run this Claude plan in a bash loop, basically a bash loop. And each time, each iteration of the loop, it's supposed to pick one of the steps to complete, build that, spend its full context window on that step, and then once that is complete, check mark that, and then it ends the session. And then the next iteration of the loop, it goes in and it sees one item has been checked off the code for that exists. And then it will go pick the key is it picks the most, what it thinks is the most important unchecked item to implement later. And it goes and does that. And it will basically keep going in this loop, checking off, like it'll read through the plan, generate a bunch of stuff, and then edit the plan.md to have this singular item checked off as necessary. And it'll keep going through these checked boxes until, like, keep iterating until the boxes are done and the project is finished. That's the whole idea of a Ralph loop, where you just completely, like, iteratively run a project until it's finished. And again, with this, the whole idea is um, it's so that you manage context correctly. Because if you were to try just one-shotting a plan that maybe if it gets too large, like maybe this might be too large, the code might actually just run out of tokens at some point. Um, what I could instead do is create a small Ralph loop where it breaks this down, breaks the project down into it's like small number of sessions, maybe 3 to 5 sessions, different modules, and for each item on the checklist to go through, it'll just go tag that, get that implemented, have it done, and it breaks it down so that again, this is all like context management. If you have a project to implement that is too large for the context of a single session, how do you break it down into more manageable chunks that the so that the project basically can get finished easier by multiple sessions? And that idea is very cool and is I think it's maybe like a couple of months old. But again, this is the like this is I guess pre like open claw. God damn, stuff is moving so fast. But yeah, again, this is I guess with that you would also want to make sure you have a very strong way of formally verifying that the code is correct. So I think within that, like the output of generated code is correct over multiple sessions. So I think within that, we'd probably also want to include a way of debugging, like a debugging method, so that um, one of the steps is to basically allow frame dumps, so that once the code is running, if there are no bugs, if there's nothing else, it will just be able to basically dump the like do frame dumps to verify that it looks correct. Like it could frame dump this and see, oh, there are some like the boxes aren't shaded fully. Um, that's something. And then it'll go update its own plan, MD, and then fill it. And then yeah, I don't know. Whew, this is interesting stuff. Damn, I really not great at talking for this long without a stay like more coherent idea of what I'm trying to say. Hmm. I don't know, maybe I gotta have more specific plan next time, but I don't know. Damn, this is taking a while. All right, in the meantime, I will, let's see, thoughts. So, are we cooked? The answer is sort of. I mean, it's actually taken me a bit longer than I expected to get this done. Um, I mean, again, I'm kind of like a beginner to all this, like using like the plan as a sort of cache, or like a collection, or like a um, yeah, some sort of cache or something, like a collection of ideas as like a filter almost. Like we just see what we want. Um, what we want to update, throw everything into like kind of iterate on the plan as needed, like what we did here. I made a generation that I didn't think was good, and then I axed that and made it re-implement that. Um, and that's kind of what we're going for. Iterate on the plan MD until the plan is solid and the plan kind of describes the code that we want. And then once we have that, this can basically just go and implement it. And if necessary, can make this, I could actually have asked it to create its own little Ralph loop thing where it breaks like change the folder structure so that it can be handled more easily by um, agents, and then more modular, maybe like three or four, a couple of different, like handful of different modules, each can be implemented on its own, um, independently. And then these all act through an API service between each other and can get implemented. Maybe that can be the next stream. Uh, break this apart into a series of Ralph loops and or break this apart so that instead of a single cube.c file, it can be done in Ralph loops. Yeah, that could work. Ooh, I don't know. Future is wild, man. I mean, yeah, after yesterday's stream, I was just kind of out there uh, on the basketball court, just shooting hoops, um, listening to a podcast, and I was thinking, God damn, we really are in a new era. Um, kind of interesting era. This is something that I have been thinking of. Ooh, there we go. It's been stamped out. But a brand new era of coding where, in some senses, layers, this isn't a new idea of any kind, of course, but it's like using LLMs as a compiler to generate code, and then using that code is then used to generate assembly executables, whatever. The plan here is almost like a sort of mid-level abstraction, but the the interesting thing is that like the abstraction now is Markdown. The abstraction is a project spec. This can kind of fill in the spec as needed. And if we wanted to, we could break these specs apart into a better project structure that would allow, um, suppose the rendering was its own Markdown module, like a module with a Markdown spec. The module could be updated as necessary. It has, there could be one module for calculating the rotations, like the rotations of the cubes at any point, then a module for doing the rendering from taking the state of the cube, putting and then rendering it into an ASCII buffer, and then another module for actually the game module that takes the output of this ASCII buffer and it like prints it to the screen. And that cube rotation state to ASCII buffer trans like data transformation can be done in its own module. And in fact, that module could contain all of the different modes. Um, so that's kind of the whole like module thinking here. And you know what? Let's take a look at what we have. Um, we've got this cube. Let's give it a shot. Oh wow, there we. Huh. Okay, that is kind of strange actually. There's another issue I guess that we have now. Let's the wireframe. Yeah, this looks good. Huh. That is strange. I guess this is what you get with going to the 3D world, but uh, you know what? I think this is a good idea. Next steps, break the main loop. Um, the cube rotation and state to render buffer into different modules. Then we can do within the main loop add a debug command to save some of the buffer frames to an output file for debugging. And then maybe we could do like have an option to run this in a custom 10-second long form and save samples of the cube rotation. Maybe we could even have the details of the run like this rotation speed, duration, number of total samples as parameters for a custom run. That is a cool idea. Bam. Oops, shit. Anyways, now let's see. Ooh. No, this is different. Updated rendering. That's all right. How does that look? I like the old one better, honestly. But yeah, okay, that's cool. You can so um with this we're kind of uh, uh showing what exactly um what exactly is going on. Um, how we can use like I've never coded in C before. This sort of 3D graphics project, this is completely new to me. Oh, there's a the cursor flickering around there. It's probably gotta hide that. Anyways, um, yeah, this is all. That's another bug. That's another something else to throw into the plan.md. In fact, honestly, I probably should be making more manual edits to the plan.md file now that I'm sort of more aware about how it works. If we just go here, take a look at the plan.md. Oh, this is not great. I like the syntax highlighting. Oh, that's not highlighted at all. Oops. Um, is that gonna write anything? Nope, it guess not. Um, huh? Okay. Yeah, yeah. Anyways, this is making me think. Oh, it still has details for the breast. No, I think the breast enhance just the. Ah, whatever. This is good enough. Good enough for today. All right. Anyways, that has been it.